Hope you had a good break. It just went so fast. I'm already exhausted. So let's just see. We have web work 0 due Sunday. I would, gosh, I'd really like to take it no later than that. You know, I mean, I will. I want you all to get. I want everybody to get 100%. It's always hard to kind of pull people into that, but that's my goal. Web work 1. We have finally begun the new stuff. So we're at a positive value of web works. This is going to be due next Friday. We'll see how that date goes. This is 18 problems. Much harder than the first ones for a conceptual reason that we're going to start talking about today. So those first ones, that first set, oh, it's brutal. It's so nitty gritty with the numbers. And PK, we were like, just that last one you were asking me about with the solving for C and D, just gritty. This one will be less gritty, but the moves you have to make are going to, this is where the growth, you will begin to grow. We're not reviewing anymore. So what are we going to do today? Well, we're going to work with indefinite integrals. And so we're gonna learn, basically the first part of this class is how to do this by hand in circumstances that aren't simple Calc 1 situations. What do I mean by simple Calc 1 situations? Let's make a table here. So this is our guide, and I'm going to write it in a really interesting way. A little box above it, because what we're mostly concerned about are rhythms in math and certainly in this class. So that's a rhythm. Here's a rhythm. Equals, it's the power rule. So I add 1 to the exponent. I divide by the new exponent and plus C on all this shit. Let's just put a big one over here for all. Share that. Happy to share that. We got this one. I'm going to write it 2 ways. And that's going to get us really far. Let's just do a sine or cosine 1. We're going to, I want these up because these are our rhythms that we're going to be using. Oh, I guess I'm just putting plus C anyway. And then last one. Plus C. Cool. So basic stuff. Yes?
So those boxes just represent any variable?
Yeah, exactly. So if I put a Z in here, Z here and Z here, but what we're going to do today is actually have more complicated expressions in there, like x squared or sine of x squared, just like much more than a single variable, but that's exactly what I intend. Yeah, so you got the meaning. So, first part of this class is doing these in a variety of circumstances. Just for basic understanding, we've come to a place in the world where computers can do everything, right? How many people have actually used ChatGPT for anything? Of course. Come on, I'm not going to tell anybody. I'm not gonna tell writing instructor. I like pass my emails through it. I write it and then give it, say, can you make this better, please? Please help me, computer friend. Wanted a robot friend my whole life, and now I've got one. Almost. Next year. So let's take a look at a simple problem. Yeah, I meant that. So the name of the game is going to be thinking about the basic rhythm that most likely matches what we have and putting this into that form. And I put those boxes up there as a psychological and mnemonic device because what we're going to do is visualize laying these over the problems we have. So right now I've got e to the x squared 2x dx. Which of those forms does this most likely fit? Good.
This one?
First one, right? Because there's an e in it, right? It's e to a something, e to a variable. So this is why having these ready and constantly referencing these is going to help you, because you need to practice finding the rhythms. So that looks like, and I'm going to write this in a slightly different way now, without the boxes. Instead of the boxes, I'm going to put a u, but the u is just a box. And this is just a u. So, PK gave us a great tip. This is the form we should be going for. When I lay this on top of the problem, what would that require you to equal? So like lay this on top, like a transparency on top. What comes through the U box? What do you think, Kellen?
It's x squared.
It's x squared. So look, the U is the exponent on the E, right? If I'm going for this form, the U would have to be this thing right here. This is the part that would come through here. Don't worry about the D stuff. Worry about the thing in between the integral sign and the differential. So here I'm going to let, because I'm choosing to do this, U equal x squared. That's called substitution. And that's what this method is all about. This is integration by substitution, in fact. So we take things that look beastly and, if possible, turn them into things we can use a table for. That's the game. And that's part of the art, like learning how to see these patterns. We're going to start out chill, and as you've seen maybe already, we're going to escalate our way up the chain of difficulty. So, step one is what I just did. Decide a possible, and I'm going to underline possible, a possible form from over there. Or maybe even, if you see a tangent, go look up the tangent form or something. And then step two is using this form, let U equal the kind of nasty part here. The part that's like, oh gosh, if that was just an X, I feel like I'd be doing pretty well right now. So let U be the nasty part, but what I mean by nasty part is just whatever comes through here. So if I see a parenthesis, if I see, let me just give you a quick example. If I saw this, something like this, and I laid this template on top of here, U equals x squared plus 3 is the thing. You don't want to see me dance, even my head bobbing. But x squared plus 3 is the thing that would come through this box, because look at what it's saying. What's in the parentheses raised to the power? It's this thing. Let me get rid of that, because we'll get to that very soon. Oh, good. I forgot what a joy it was to work with this board. Okay, so get out of there, nasty. So step 2 is do this. I freaking erased it. Step 3 is find the differential. Find the differential of your substitution. And all that means is the du part. So, find the differential, i.e. differentiate each side of U equals whatever. On the left, it's always going to become du. So the left side is just, and you can think of that d as derivative of. It really makes a lot of sense to think of that as derivative of when I write u. The right-hand side is going to be d dx, probably, whatever your variable is, of that side. So coming back up here, left side goes to du, always. Right side, what's the derivative of the right side? And with respect to x?
2x.
2x, yeah, power rule, beautiful. And I tack on a dx. But otherwise, it's just taking the derivative. Let me stop for a second. I unfortunately left my tea in my office. It's quite a drag. No beverages. I went downstairs and the line was long. Questions on this so far? And you might need to see this kind of happening to really understand what's about to happen. Let me refresh. I saw this. It looks like that. The u is the exponent here, so I let u equal the exponent, and then I differentiated both sides. Cool. So now there's lots of ways a person could think about this, but I think a straightforward mechanism would be step 4. Step 4 is where I solve this equation for dx. So solve the differential equation that you just produced from step 3 for dx. So dx here is going to equal to du over 2x. Let me stop. Just isolate this. It will always involve division or multiplication. It will never be addition or subtraction. Then, rewrite the original integral using this and your substitution. So I'm going to call this star. Is that a question? Yes, sir.
Why is it du over 2x?
Because I'm solving for dx, so I divided by 2x on each side.
Oh, I see.
Does that make sense?
Yeah.
Yeah, cool. Good, good. I was wondering, I saw your eye. I thought like the brows furrowing and stuff. So step 5 is to sub u equals whatever, and that's from step star. Lots of parentheses there. And du, dx equals blah, blah, blah from step pound right here into the original. This seems like a lot. This is actually going to flow really naturally once we get rolling. So what that's going to look like is I have integral e to the x squared. Well, x squared is u. Right? I said I'm going to replace x squared with u, so I'm doing it now. And then I've got 2x. I'm copying that over. And then the dx gets replaced with this expression. So I've got du over 2x. Take a look at that. And let me know if you see anything awesomely mathematical that you would want to do. Right? That. We want to do. Can't. Bop. Was it a bop?
It was a good bye.
Goodbye. Adios. Bye-bye. So this turns into integral, or just integral e to the u du. How sweet is that? I turned this problem into this problem. I'm hiding all the stuff in the u. I'm hiding the ugliness in the u. And then now it's table time. What is that?
Exponential.
What should I write?
Positive to the right.
Yeah, what am I going to write? What is that equal to? What is the antiderivative of e to the u?
Oh, e to the u.
Beautiful. What was the variable our first problem was in?
U.
What was the, look at the very original.
X.
X. So the original variable was x. I got to get back to this because my boss is paying me $1,000 a day to do these things. I should at least get them back. Oh my God, if I could do that, that would be a sweet life. So the last step is step 6, and that is back substitute. So now we're going to use whatever our u substitution was and replace it in here. So this integral, now I can rewrite it. The original integral, e to the x squared 2x dx is equal to e to the x squared. I'm just literally plugging x squared in there, plus c, and I'm done. And let's check. The great thing about calc is you can always check yourself. How can I check that this is true?
Work backwards.
I can differentiate.
Differentiate. Yeah, work backwards or differentiate. Yeah. So the check is this. I'm going to take the derivative of e to the x squared. And the way to do that is maybe look in the table that says integral of dx of e to the something is the e to the something times the derivative of the exponent. What rule is that from calc? Let's play hangman. This is just the
Is it 2x e x exponent x chain rule?
That's what I was looking for. Yeah, you were thinking about the math. I was thinking about the rule. Oh, you saved us. Nobody's hung in here yet. This is great news. Thanks, PK. So this is the chain rule for differentiation. So to take this derivative, I just go, oh, that's copy down the original problem times the derivative of x squared. And that is just 2x. Done. And that is our original integrand, so we know we did it. Questions?
Oh, it's 2.
Yeah. Is that something? Yeah. Awesome.
I'm good now.
Awesome. So let's amp this up a little. Oh God. Okay. I wonder if I like wet this eraser. That would make things better or worse. If it makes things worse, we'll
I
just
call it.
you're hoping for it.
I actually don't know. I actually feel like that wouldn't work.
Yeah, I don't. But this. Oh, look at that.
Well, that technique is.
That's pretty.
I'd say that's a different technique.
It is a completely different technique. You're right. It's kind of a hybrid, but it's working really well. It's probably the cleanest we've had this board forever. All right, so let's do a slightly different problem. Let's assume I'd had this. I'm going to do it a little bit different. Kind of the same thing. What form are we looking at?
E to the first one.
Top one. Yeah, it's an E. I see, if you see an E in the problem, this is probably your first guess. Somebody can be a tricky bastard and really throw a loop in it and get you. But you might have to do these problems a couple times. You make a guess, it might be wrong. And you'll find out it's wrong, and I'll show you how, but not in this example. So here I'm going to let u equal x squared. Keeping in mind this is the form I'm shooting for. Lay that on top of here. The x squared comes through the u window. Take the differential. Solve for dx. Do the plug. So I'm going to plug this in, and I'm going to plug this in. So the integral, let me write what I'm doing here just so you can see. I'm letting u be replaced with x squared, and I'm letting dx be du over 2x. So this is going to turn into integral e to the u. That x is still there. Notice I'm not doing a dang thing with the x. I'm carrying it along. Only thing I do with is what comes through my window in my formula and the dx to du sub. So then dx gets replaced with du over 2x. And now I cancel, but I don't cancel completely this time. What cancels?
Just the x's.
Just the x's cancel this time. So now, just those guys cancel. So I'm left with integral e to the u. This is a half, and I'm going to put it out in front. Just pull the 1 over 2 straight out in front. du. Stop. Check that out.
So, do you always have to divide by the 2x?
You should, I recommend it. There's other ways to think about this. And if this ends up not thinking from, I'll show you how I learned it. I learned this later in life after teaching, and I think it's a little more foolproof. So yes, for now, until you become a master. And then you can do it any way you please.
Gotcha.
As long as it's right. So look, I've got this 1 half out in front, and we're gonna see this a lot. It'll be some multiple of one of those formulas on the far right. So this is just 1 half. This is just e to the u. And then we don't need to, the c, you don't have to multiply it by half. It just absorbs all constants. Now I back substitute. That's the BS there, not else, other things. And I'm done. That's my integral. That's my antiderivative. We can check that out with differentiation, but we're not going to. We're going to keep moving. Let me know if that sounds all right. I'm going to do some little more erasing. I'm going to try.
Oh, that's just saying it's divided by 2. Two can cancel. So it's still 1 over 2.
We ready for more here? Alexander, did you have a question?
I want to see it more.
Oh yeah, I think that's a good, I think it'll start to resonate when you see the commonalities. So let's take a look at another one. Let's say I've got x cubed plus 7. I've got that raised to the 10th power. Good gosh, that's terrible. But I got an x squared dx out there. So one way to do this with Calc 1 knowledge and a lot of time is to actually figure out what this polynomial looks like. So multiplying x cubed plus 7 by itself 10 times. That is a non-trivial problem, and it'll be worse than any web work I'll ever give you. It'll be a beast. So that's one way to do it, and then distribute the x squared and just use the power rule. Could do that. But what I could also notice is that it looks a lot like something in parentheses raised to a power. So now keep an eye out. This method, parentheses are big green flags. They're not red flags because we're stoked we're doing calculus. So these are flags that show you where the substitution is most likely occurring. So when I come to this and I compare it, let me write it right underneath. What is my substitution going to be?
X to the 3rd power plus 7.
Beautiful. Yeah, you looked inside the parentheses, right? Yeah. And honestly, sometimes thinking too hard about this can be a real deficit. Let's finish this up together. What's du equal to?
X squared dx.
Pretty damn close. What's missing there?
The 10?
How do you differentiate?
The 3.
Oh,
3, yeah, you forgot your 3. Does that sound right?
Yeah, I forgot about that.
Awesome. Cool. And then I'm going to solve for dx, and that's going to be du over thrice x squared.
Like 3x squared.
We all good?
Yes.
Yeah? Awesome. And so now I'm going to substitute. So here's my sub. I'm going to rewrite the top integral. as that form. And so it's going to be integral of u to the 10th. Remember the u was the x cubed plus 7. I don't need parentheses. I could put them, but don't need them. And then the x squared was there. We haven't talked about it. We're copying it down. And then we're going to sub in dx is this thing. Does anything cancel? Yeah, stuff cancels. The x squared cancels. So here's a way to know if you've done this right. If you get to this spot where we sub in everything and all the previous variables don't cancel out, you have screwed up somewhere. You have either screwed up in the choice of what your substitution is, or your calc is rotten somewhere along the way. So this is the x squareds cancel, and just seeing that x squared appear fills my heart with glee. Because now I've just got a 1/3. I'm going to bring that out front. Always bring the 1 over 3 out front. U to the 10th du. And that is just a power rule. So the 1/3 comes along. Bump up the exponent by 1. Divide by the new exponent. Plus c. Yes?
So why did you keep the x squared over here? I didn't catch that.
So there's always going to be a few extra variables or constants floating around, and we just focus on the thing that is clearly u and the dx, and any other variables that are floating in there will cancel out ideally for us. And so let me say it a different way. Let's look at this original problem. This is part of the derivative of something bigger. So if I, for instance, let me finish this up and then I'll show you. I think this might help. So this is 1/33. U is x cubed plus 7 to the 11th plus c. So let's take the derivative of that thing. The derivative of that, so here's our check. d dx of 1/33 x cubed plus 7 to the 11th equals, bring the 33rd out in front, do the outside first. This is chain rule. So I do the outside first, treating this inside, I don't even look at it. So I bring the 11 out in front, x cubed plus 7, decrement, exponent, times the derivative of the inside. And look what happens. That's going to cancel. My brain's exploding. Oh no, I'm good. I'm good. I'm scared. I was losing a 3. Let me finish that up. So that's 1/3, right? Because 11 over 33. X cubed plus 7 to the 10th. What's the derivative of this expression?
X squared.
Beautiful. Thank you. And now look, that 3 and that 3 cancel. And so x cubed plus 7 to the 10th x squared is the derivative of that expression. And that's exactly what I have as the integrand up there. So that x squared is actually part of the derivative of the bigger thing we're trying to find. And it comes out through differentiation, which we're not going to mess with. I don't know if any of that helped you feel better about this. Okay, all right, I'll take that. That's pretty good. It's not a no. So you're saying maybe.
Yeah, I'm getting it.
All right, cool. Let's do one together. This I'm going to let y'all work on this one. And yours is going to be a little chiller, quite frankly. We don't go into the weight room, and well, I don't ever go into the weight room, pretty obviously, but we go into the weight room, we don't pick up the heaviest weight. We work our way up, we get warmed up. So please, my friends, oh, what a vast rate. 3x plus 5, just like those odd numbers. Do we have any forms that look like that? No, we don't, but how could I make it look like one of those forms?
You make
Put it
the
to the power.
square root into the power of one of the two.
See, look how much you've already learned. Last week we did this, nobody knew what the hell to do. This is great, we're learning. Oh my God, let's just call it. No more, we'll just actually go take the nap I felt like taking.
Yeah, I'll pass the class now.
That's right. So your turn,
Okay.
give it a shot. I'm gonna go try to find a beverage of some sort. Probably money's needed. No, I'll just go drink out the damn faucet.
You.
Know how to do this one.
Just thinking it over in your head.
Okay. It's good because I'm going to ask you to help me, Kevin. So, you done here? Okay. Oh, that looks so good. So, yeah. Oh, sorry. I thought I saw 2/3, not the other. Oh, yeah. So nice. Power, right? Master of the universe. Or at least that count probably. That's how you become master. You have to start somewhere to be master of the universe. Most of them start in Calvin. Teamwork, love it. Everything you're making, feeling good about this?
I don't know if it did.
Let's take a look. So, it's an interesting idea. So, this new exponent should, a couple of things. So, once you actually do the integration, get rid of the integral sign, because when I look at that, and you might look at that at one point and think there's more integration to do, so let's get rid of that. And then the other thing is this exponent up front is identical to your new, oh no, sorry, it's right, you're right. Yeah, yeah, got it. That's all good. So that looks great. Don't you think that's really good? How are we doing? It's getting real, okay, cool.
I don't know, I have no idea. I'm lost myself.
Uh-oh. We're lost. Let me take a look at where you're at.
Yeah, I don't know where I'm at actually. I've done some nonsense.
Cool. I think I might actually let Kevin off the hook and let you work this one through with me.
Oh, wow.
Oh, I know.
Wow, I must have been really bad.
No, I honestly, no, I barely looked at what you had there. I was listening to you more than anything. What form am I going for here, Alexander?
The second form?
Correct. Power rule. Yeah. So we're going for this
That
one.
should be separate, my bad.
It's all good. No, it's cool. That's also a completely valid answer. Exactly. So what would you be here?
3x plus 5.
Perfect. You seem to be doing pretty good so far, frankly.
I got that.
Okay, what's D?
3.
Yep. And then we tack on the dx. Don't forget to tack on your dx. And then I solve for dx, and what do I get?
Oh, that's what I forgot was the dx. Do you get du over 3?
Yeah, and I kind of like to just put them as fractions out in front because I'm going to pull them out in front eventually anyway. So just a recommendation to, it's du over 3 was completely correct.
Nice.
Just helps the brain a little to have that there. Cool. So when we rewrite, what does this become?
It becomes the integral of u to the 1/2 power dx, du.
So dx.
Times the d, yeah.
That thing. Now pull that 1/3 out in front.
And you have u to the 1/2.
Sound good?
Yeah.
What's 1/2 plus 1?
1. 1/2 plus 1/2 plus 1, 1.5.
1.5. I like 3 halves.
Three
Yeah,
halves, yeah.
same thing. What do I put up front?
You put 1. Let's see, wait, this 1/2. Is it 2/3?
Correct. You seem to know a lot more than you claim. I think you're bluffing. So this is 2/9 u to the 3 halves plus c. What's the last thing I do?
You put it back into the original with x.
Exactly. So
Back
I've got,
substitute.
yep. So back substitute. I've got
Use
3x
3
here.
plus 5 to the 1 negative 1. Or just. Oh yeah, just 3 halves because we just solved that.
We've what all the calculus is done.
Yeah.
Yep.
I agree.
Beautiful.
Now I'm just gonna do that myself.
Does this feel better? You were close. You were pretty big question. Oh, good. You got it. Okay. Awesome. Any questions on this? This is the game. Okay, let's make it. The game will continue to escalate. We haven't met the boss yet. Are anybody here gamers? Gamer? What are you gaming? What are you playing right now?
Let's see. I don't know. I'm busy. It's good. So, but
Okay, that makes sense. Who else? Anybody else gaming?
I'm not a massive gamer. I'm going free for.
Oh yeah. Yeah, I'm doing the Elden Ring DLC.
You know about the Elden Ring deals?
Dude,
Hilarious.
I'm like a
So funny.
hardcore gamer.
Are you
Like
serious?
seriously, yeah. I probably played Dark Souls 1 for like 800 hours.
You're like into it. That's like serious time.
Hopefully.
That's serious time.
Yeah, well, when you're a loser, that's what you do.
Come on now.
Why, are you a gamer and you were lying about it?
No.
Oh
Well,
my God.
I don't play like
Oh
I.
my god.
You should film him.
I have long distance friends who I connect with via video games.
Yeah, it's cool. And it's like a social event for me. I get
Yeah.
together with my buddies twice a week and we
Play the
Play
Elden
co-op.
Ring DLC.
You know it. All right, so let's try another one. Cube root in the bottom, 2x plus 1 dx. That is a cubed root. I'm definitely going to have you help me with this one, Kevin.
okay.
So for this question was that
The previous one?
Yes, that bottom part is the final answer.
Yes.
Okay.
What is this mess? We get over you.
So don't forget, convert it to a power, right, with parentheses and a power. Should have a negative power.
Okay, so that's one. Oh, wait, it is square root's a fraction power, right?
It is a fraction, yeah, so we have a fraction and a cubed root. Oh, fractional power, yeah, that's a 1/3.
One
so that's-
third. What's on
yes.
the bottom? Like negative one
So
third.
I'll get a little help here with the initial conversion. This is, if you don't do this, you're lost. It's just not gonna hammer out.
Oh, it's literally exactly what I had.
Good, fantastic. Well done. Looks like you're going for the one over U4. But what's this? That's a good first effort, but it's not gonna work out, and I'll tell you why. When you go in to make this sub, let's take a look at it together. When you go in and replace this dx with this, and then you replace u with this, you're gonna have a lot of x stuff floating around that doesn't cancel. Do you see that? Check that out. See that? So for this one, if you have something with a parenthesis to a power, it's almost always that second form, power form. Okay. We'll do one just like the one you were wanting to do there in a second, so I can show you the difference. Yeah, let's see. Okay, so here. Yeah. Okay, hold on a second. So I think you're doing too many steps at once and not some of the others. So do you mind if I just hold this? Thank you. Good, this, absolutely. Absolutely. Beautiful. So, oh, actually, you're doing fine. You just didn't make the sub inside here. That's all. Yeah, so then you did that up here, I see. I think. Is that still negative 1/3?
No, because we had the one, that's 3, minus 1 plus.
Gotcha. So let's just just a little slow it down, I would recommend. It's cool, and just for your own safety, you know? Just like write a little bit more, so I would just do this intermediate step, like that. Which is what you did in your brain. And then when you actually use the rule, the integral sign goes away. So get rid of that because it indicates there's still calc to do, but you've done all the calc. Does that make sense?
Yeah.
Okay, awesome. Otherwise, fantastic.
I think I'm done.
That looks really good. So good. So okay. You haven't integrated yet. You actually didn't do the integration part yet. So you got to here, and then
Actually, supposed to be 2 or 3.
yeah, and there was nothing wrong with this, but let's kind of scratch that because that's not quite. You jumped ahead too much. So let's rewrite this as 3/4 integral u to the negative. Was it negative 1/3? Yeah, negative 1/3 du. Because when you substituted the dx,
Oh, yeah.
yeah, right? So at this point, we're hoping everything is u's. And now put an integral sign in front there because that indicates calc needs to be done. Now take your antiderivative. So you're gonna have 3/4 times. Yes. Beautiful, very nice. And then now the du goes away too, so the integral sign and the du live, they only exist simultaneously.
Plus C.
Plus C, and don't forget your 3/4 that you put out front originally. and then plus C, and you're done, back substitute. Yeah? Okay. Stellar. Let's see where you guys are at. How you guys doing here?
Lost. I made it here.
Would you mind?
Yeah, go nuts.
It's done. That's how I wake up. So, still got an inner.
Oops, it's on erasing run, that's my bad. I totally.
It's okay, it happens to me a lot of
I
times.
was thinking we're gonna do
Give me
that
one,
one.
thank you. So you still have an integral sign, right?
Yeah, which is what I had here.
Yeah,
It's the
yeah.
same thing.
It's
Yeah.
just, but let's be, one of
I
my
got
big
you.
things
I hear
is
you.
consistent
I hear you.
notation, and I'll talk about that in a minute and we'll preach about it. So you've got now 1/2, you're just gonna carry that along, the 1/2's gonna go in for the ride, and then the power rule, that second thing.
Mhm.
So what are you gonna do to that exponent?
Power rule, is that what I'm doing? To the exponent for this? Really?
What's your exponent?
Negative 1/3.
Yeah, so what's your new exponent?
2/3, yeah, 2/3.
2/3,
Yeah, 2/3.
and then put a 3/2 out front. Kevin, walk me through this, friend.
Alright,
What is my u gonna be?
U is going to be 2x plus 1,
Beautiful. And then my du?
2.
Dx, yep. Cool, so, one of the things, and sorry, we'll come back in a second. One of the things I was just telling Alexander, I was like making him write that integral sign. This is technology. So first off, just language is a technology. Writing is a technology. The first one that humans probably, well, fire probably, right? But then writing was like one of those super sophisticated technologies. Math language is a technology to offload thinking. This makes it easier. The more you understand your notation and use it, the less your brain has to do. So that's why I'm going to be a real stickler about integral signs and just making everything look nice, because it helps it solidify in your brain. All right, so Kevin, where do I go next?
Next you're going to rewrite the equation. It will be, yeah, so it will be the integral of u to the negative 1/3
Beautiful.
and 1/2 du.
Yeah, and so Kevin did this in, we didn't talk about it, but just moved that 1/2 over there to isolate the x, very nice. And so then this became this. Lovely. Where next?
Then you can move the 1/2 outside the integral.
Outstanding. I'll just do that as a small step. Next, please.
And then next you're gonna integrate the u.
Awesome, perfect. So where does that go to?
It will turn into 3u to the 1/3.
Let's see. So no, because we have negative 1/3 plus 1. That won't be 1/3. What will that be? What's 1 minus 1/3? How many thirds you got left?
2/3.
2/3, yeah. So 2/3. And then out front, instead of 3, I'm going to have 3/2. Does that make sense?
Yeah.
Sound good? Awesome. Plus C. And now all the hard work is done. Notice how these two are married. These two, when one goes, the other goes. They are gone because I'm done with calculus. So now this is just 3/4 u to the 2/3 plus C, back substitute. Notice how I'm notating even to myself. Even though I could do this stuff in my sleep, I'm still notating it in case I just want to know what my thought process was. And so then I back substitute to 2x plus 1 to the 2/3 plus C. How do we feel about this? Yeah? Vincent, you good on that?
Yep.
Okay, awesome. So, awesome, well done, folks. So this is kind of like the intro level stuff. Let's take, it's not gotten out, there's a dark forest ahead and we're gonna go in together. But don't worry, we'll hold hands in a circle and we'll be safe. Where the fuck is the little wipers? There. Okay. And you guys get the cussiest version of me. By this time of day, I'm letting F-bombs fly a little more red. Oh, you. That blue pen is a bastard.
At least it's not the red pen, that probably would've been way worse.
Oh gosh, yeah, that's true. But seriously,
This is pretty bad too, though. Yeah,
this is terrible.
yeah. Well, it was the WD-40, wasn't that?
Yeah, you're right. I forgot the WD-40. Now I need like car wax. It feels like I'm waxing a car. Like I have to grind so much. Do people even do that anymore? Like put on that hard wax and
Only for martial arts training.
yeah, I'll love the reference. All right, well that really sucked. I missed that. That's okay.
He didn't understand the wax. It's
Oh,
fine.
wax on, wax off.
I get it. Yeah, exactly.
All right,
Right on the money.
take control of this problem.
Same thing?
Not exactly. Look at your forms on the right side of the board. Decide what form it seems most like.
So this one's never useful. Oh. Natural log. It's natural log. Cap just disappeared.
Oh gosh, okay, more water. It really expend a lot of moisture, I guess, while I'm walking around up here doing stuff.
Okay.
I forgot. Announcement. I'll put it up here. I'll talk about it. What up? What's up there? Alright, come on, baby. Let's clean this up. No more blue pens ever. That's a cool sound. Isn't that crazy? The laser. So I heard Alexander say, bless you, the right words. What form were you going for?
Natural log.
Natural log form. We got a fraction. When you have a fraction and there's no parentheses, that's probably a natural log form. So keep an eye out for fractions without parentheses in the bottom, and give this a shot. So if we're trying that, that's going to be our u. We all feel like
Yes.
right about that?
Correct.
Yeah, it's the denominator, right? And then du 7dx. We're really almost done. And that's kind of the hard part, is seeing it. And then just, I've done the differentiation. again, I'm not writing du over 7, I'm writing 1/7. And so I can help my mind in the future. I'm paying it forward. And future me will always thank past me. I'm gonna try to move a little bit faster here. You tell me if this sounds okay. Yeah. Woohoo! Getting it. Oh, rocking it. What's your shirt about, Alexander? Is that a band shirt?
No, it's there's a group of DJs.
Oh, cool. See, music related. For
Yeah,
sure.
anything
I got
related,
that vibe
yeah,
from.
yeah.
You just good to not forget the absolute values on the argument.
I'll be good.
That's our answer. Let's see if we all agree. Yeah, outstanding. Gentlemen, agree? Feel good? Oh, looks beauteous. Well, it's time to get in my magic book of harder problems. Things I've created for us to have fun with. Exactly. Okay. Next, fun problem. There's questions on this. I should stop. I haven't asked for questions.
Is that the final form?
That is the final form.
Okay. Then I'm good.
Outstanding. All right, here's a fun one. Integral of e to the sine of x cosine of x dx. That's not even the evilest thing I'm seeing on this page, so you're welcome. What form are we using?
The exponential, the first one.
Beauteous. First form. When I see those cosines canceling, I know I did it right. When your final sub-integral is all u's and just constants, new constants, you know you've got it. You know you made the right choice. Or you've done enough things terribly wrong to get you to the right spot somehow. But probably you got it right.
What happens to the negative?
So explain what you mean by negative. Thank you.
Sine to, oh, because you're derivative, okay, I got it.
Awesome. Beautiful. I love that you're thinking about it though. And I love that you were asking about it. Beautiful. Any other questions on this one? Let me give you another one that's related. Pretty close, pretty dang close, but not the same. Let's do this one. Uh-oh. Think a bit.
What'd you say about?
Because this is probably the trickiest one I would say so far. You gotta make a call on what form you're gonna go for. My hint is look for parentheses. They're always cueing you into something. Cueing you into composition. And when I say composition, I mean composition of functions, and that's what this is all about. I'm going to do it wrong right here and do something that doesn't help. So just so we can talk about it, because at some point you'll do this thing that I'm about to show here. But just keep working, I'm just going to write it up. And if you are done, then you can check this out.
Yeah.
You might misidentify a form occasionally. You might think, oh, it's this thing.
U equals F.
You shoot for it. But all this does, and you will at some point probably say, I'm going to let u equal x. But all you do is rewrite the problem. So it doesn't really get us anywhere. It's because this problem then would become, oh, it's integral sine of e to the u du. Everything's perfect. So it's like, same problem. Nothing moved. What form should I be shooting for? Sine form. The parentheses, look at the parentheses. There's something going on here. And then I come over here and I see those parentheses. The parentheses are the window where the substitution will fall. So I look here and I go, oh my gosh, yeah. All right, I'm gonna try u equals e to the x. Now that's cool. Du is derivative of that, which is the most beautiful derivative in the world. Dx, solve for dx. Sub, this becomes sine of u, e to the x, du over e to the x, zip, this is integral sine of u du, that is by the table, negative cosine of u plus, now there's the negative, Calvin, now I got a negative. Back substitute, negative cosine of e to the x plus c. In some ways, you're like ready to take on the world, for sure. The world of integration by substitution, but I want to give you one last one. Let me know if, take a look at that and let me know if there's any questions. And one last one. Oh, math club. Today, I'm glad I put that up there. I knew I'd forget it. So math club is pretty chill. You might think like, oh God, I just did an hour and a half of calculus. Do I really want more math? You do. Because we'll have ice cream. We always have snacks, and people come and they just hang out and work on problems in their own. So I don't know how nerdy you guys are, but I don't like social situations. I mean, I put on a show here. I spend all my money, my energy, and not my money, I guess, or whatever, being here putting on this show. But when I'm home, I don't want to talk to humans. I hate parties. I don't want to go to a party and have some insipid conversation about garbage. If I want to get drunk, I'll drink at home. I don't need to drink with people. I'll drink alone, the healthy way. And so it's a place where a bunch of other people like that hang out. And you know how you go to a party and sometimes it's great that there's a dog? Because then you can talk to the dog, and it's a bad party, so everybody just hangs out and talks to the dog. Oh, hey buddy, and you're like, oh, I wish the dog was here so I had something to do. The dog is math at this party. And so you come, you sit on your own. You don't talk if you don't want. You can be silent and just eat and drink and work on math and be in a semi-social situation. So I encourage you to come. There's no pressure, you know, and there's no pressure. But it's in the math suite, math physics suite. Last problem. We got 5 minutes.
All from math though. That was wild.
What's that?
I'm officially lost. I don't know what just happened.
Crazy. That was
Really?
math club. Like I don't really know where the path that connects those two.
Yeah.
Party dog. I loved it. That was great.
Yeah.
Well, welcome. Yeah. Hopefully it's not too shocking by this. How many times have we been
It
together?
kept me really engaged in the math club conversation because I was like trying to figure out what you were
Yeah.
saying.
So all I was trying to say is dog, math, food.
That's all you needed
Dog,
to say. I'm
3:30.
there.
Gotcha.
Your turn.
And where's the AMP?
Do you know where the physics and math profs in Carroll Hall?
Carroll Hall.
Carroll Hall, I think it's like the first floor.
What over here?
Yeah, yeah. How would you explain to get
Oh,
there?
just climb over the stairs, I think it was on the left.
Is it the 108 room area?
Yeah,
It is.
it is.
Sick.
So it'll be in there, just in that lobby.
Just there. Gotcha.
You're just gonna go get a good spot at math club. I know I gotta go. Bye. Thanks. We have ice cream today, apparently.
Say it again.
That one? What we're doing right now? Cooked.
Yes.
We're cooked.
Exactly.
No.
Could.
No, it's not one.
Well, let me rewrite this a little differently. I like the way you're thinking, but there's 2 ways to write it.
Doesn't help.
Yeah, it doesn't help.
So there's here, the key thing is there's a fraction and there's no parentheses in the fraction.
But there's also a letter.
Explain more what you mean.
D. Like
Well,
you're
D is
implying like
just
DX,
that derivative.
DT, D something.
This is the bottom, this is the derivative of the denominators on top. That's just the way to read that. So there's a thing on the bottom and it's derivative on top. That's how I read that.
Mhm.
All right, we only got a couple of minutes left. Somebody tell me what I should let you be.
The bottom part.
Yes. What is that?
DX. plus
Thank
the
you.
negative X.
Yes, thank you.
The denominators, I should have said.
What's du? No, I just wanted you to tell me the expression, so it was good. I was still not accepted that.
Oh.
What's du?
DX, you don't subtract. Which is you
Kellen, what's du?
E to the x.
Good start.
That's part of it.
Yeah. Yes, awesome. Yes, absolutely.
And then I think you have to chain rule the second part?
You
Or is
do.
it- Yes, okay, so then e to the negative x, and then
Like that.
the negative 1 does something.
Yeah, let's write that. Okay, let's write that out. So if you need to take the derivative of e to the something, you just copy the e and you take it times the derivative of the something. That's the chain rule for exponentials. Here's a great form that you should keep handy. E to a constant times x, its derivative is 1 over the constant e to the kx. So that's just good, useful information to have about. So here, the derivative of x is 1, so the derivative of x is 1, so I have kind of a secret times 1 there. Derivative of negative x is what? Negative 1, and I think you said that, Kellen. So I've got a negative there, and if I rewrote this, I put that in parentheses, because that's all that times dx. Do I see this anywhere in the problem?
The top.
Yeah.
Numerator.
Yeah, so when you start to see, when you do this and you start to see patterns here that are in the original, you are on the right track. So now I say dx equals du over this beast, e to the x minus e to the negative x. And now I do my sub. So my sub is going to be integral u, I'm going to leave that nasty top apart, dx. When I solve for dx, I get this. So it's du over that nasty part on top. Huzzah! They cancel. Oh, I got my sweet little throne here. And I'm left with integral of du over u. What form is that? Natural log. Natural log. Back substitute. It is natural log absolute value of e to the x minus e to the negative x. Excuse me, e to the, what was my sub? Plus. So I'm putting the u back in. Plus e to the negative x plus c. That looks pretty sloppy. I can rewrite it if it would help. Friday's a work day.
Is it e to the, what's the final solution?
The final solution, let me write it more cleanly. It is natural log absolute value of e to the x plus e to the negative x.
Like you said.
Thanks. See you all, friends. Bring your laptops on Friday, please.